Frequency is the number of cycles per second passing a given point. Wavelength is the length of one whole wave cycle, crest to crest or trough to trough. Phase is the measurement of the position of the certain point along the wavelength. Phase difference is the amount one wave lags behind the other. In superposition, two or more waves cross. The superposition is the resultant displacement, which is equal to the vector sum of the individual displacements. Longitudinal waves vibrate along the direction of energy transfer. They have compression and refraction. A type of longitudinal wave is sound. Transverse waves vibrate at right angles to the direction of energy transfer. Types of these are EM waves, ripples in water, through magnetic and electric fields. Polarization causes a wave to only oscillate in one direction. They are transverse only. They vibrate at right angles, which proves why light polarizes. Radio and TV aerials have horizontal rods to get the polarized signal. The normal is something that you travel through. A vacuum is an area considered to have no matter. A node has zero displacement, whereas an antinode has displacement and is the max displacement. A stationary wave is caused by the superposition of two progressive waves of the same frequency moving in the opposite direction. No energy is transferred from these waves. If you have a glass tube and a loudspeaker, you can produce stationary waves. The powder in the glass tube produces a pattern of node to antinode. Using a microwave transmitter, you can connect a loudspeaker to a probe with a metal plate behind it, and if you move the probe, you can find out where the nodes and antinodes are based on how loud the noise is. If the stationary wave is first harmonic, it will have half a wavelength. If second, it'll have a wavelength. If third, it'll have 1/2 wavelengths. Coherence is when two or more waves emit waves at a constant path difference. Path difference is phase difference in terms of wavelength. The diffraction pattern of a monochromatic light shows where there is constructive and where there is destructive interference. White light, however, gives a spectra of colours. You can measure the wavelength using Young's double slit formula. Examples of diffraction gratings are compact discs, separation of spectral lines with atomic transitions, which identify light elements. In optical fibers, light hits the cladding at an angle greater than the critical angle. Total internal reflection is caused by low refraction index. Loss of data is caused by either absorption or dispersion. In absorption, there is a loss of amplitude of the signal, which in turn reduces the signal. Dispersion, however, causes pulse broadening, which causes the signals to overlap. There are two ways this happens. One is by modal dispersion, where light enters at different angles, so some signals end up being quicker, which means the signal information is lost because it arrives at a different time. The other one is material dispersion, which is when it consists of different wavelengths, which are also at different speeds, which causes some of the signals to be quicker and also causes overlapping signals.